Welcome to Techstination. Joining us is Tyler Collins, Vice President for Enterprise Accounts at PrecisionHawk, and he's also an inventor. We're going to be talking about that. Thanks for joining us, Tyler.
Thanks for having me. I'm looking forward to talking.
Tell us a bit about PrecisionHawk to start with, and then we're going to talk about today's news.
Yeah, of course. So PrecisionHawk is actually one of the older commercial drone companies in the U.S. And I say older. We've only been around for 10 years, but drone years are like dog years. It seems a lot longer than it's been. But our company is focused on, using drones in the enterprise space, primarily with large infrastructure companies like electric utilities, helping them collect data and then processing that data with analytics such as machine learning to help them really be able to extract a lot of actionable value from their infrastructure. For example, electric utilities can use it to find where there's damage on their telephone poles or where vegetation may be getting close to those utility poles. And we can really help them increase the reliability of the electricity that's being delivered to everybody.
And today you're announcing a couple of patents that you were directly involved in. Tell me about it.
Yeah, of course. So, although PrecisionHawk is a drone company and we go out, we help fly drones, we process data and analyze data, that's not the end of the capability that I think everybody thinks that drones are going to be able to do over the next couple of years. We're all excited about package delivery. Companies like Amazon have been talking about that for years. Companies are now talking about flying taxis and being able to go, short distances in electrically powered helicopters at low levels. And a lot of this probably taking place in very dense urban environments. The Bay Area, which can alleviate some of the traffic on the roads, getting from, say, San Jose to San Francisco, delivering packages, medical devices, medicine, and so forth. And so a number of years ago, outside of the drone work that PrecisionHawk does at its core, we saw a potential need for, really what could look like an air traffic control system in the sky. And ultimately, what we're announcing tomorrow is the award of several patents around these automated air traffic control systems for drones that very much resemble what the air traffic control system is for airliners today, except pulling the human out of the loop and being able to automate a lot of that control.
That sounds pretty exciting because I guess if some of the things you're talking about come true, there could be a lot of traffic up there.
There certainly could be a lot of traffic. And I really liken it to what aviation looked like in the early 1900s. It was very much the Wild West. Planes were flying. There was no air traffic control. They would just take off, go where they're going, and land. That was okay for a while until about the 1930s when more accidents started to occur because it was hard to keep airplanes separated. Airplanes wanted to fly in more adverse conditions like weather, where they need to be able to have somebody help them keep their aircraft away from other aircraft, and especially congestion around airports, which is ultimately where the birth of air traffic control as we know it today came from, is somebody sitting out at the St. Louis airport in a chair with a flag and saying we need to coordinate this a little bit better. And so we liken it, in a very similar way to how air traffic control was born with manned aircraft and then developed over decades with new technologies such as radar, voice communication, to be able to safely navigate today, up to 30,000 different aircraft in the sky over the U.S. at any given time to safely get them from origin to destination. And we liken it very similar to that of we've been able to fly drones for a long time now. But we want to be able to do more. We think there's a lot of benefit to society with a lot of these ideas that companies have. But really to do that with all of the congestion, we have to have a safe way to keep those drones separated, not only from each other, but also from the manned aircraft that they're ultimately sharing the sky with.
And would this require new hardware on the drones themselves?
So we think it will require new hardware on the drones, although it's still a little up in the air of exactly what that's going to look like. And what we're talking about and what we've prototyped over the years has been really much more around a framework of how we keep the drones separated from a navigation standpoint. But in order to do that, you have to communicate with the drones. And so we do foresee a potential need for additional hardware on the drones, and that may look like a satellite transceiver, potentially a cellular radio, like the ones we have in our phones, so that the drones are able to get their information into the air traffic control system. But the benefit of that is a lot of this technology is already miniaturized. It's already very well developed from the consumer and enterprise spaces, that it shouldn't be that onerous to put on those drones. And also, there are many drones flying today, millions of drones already flying today. And I don't think that's going to need to be required on every single drone, but probably only the drones that want to participate in these more urban environments that are much more congested, where they need to participate with an air traffic control system.
And would they be only needed on drones of a certain size, the way I guess permits are needed today?
So that's a likely way that could go. Those discussions are currently happening right now, and there's even discussions about even how do we remotely identify who's flying drones today. So these are active discussions that are currently happening. So there are discussions of, well, if it's under a certain size, do we really need to put that additional equipment on it? If it's a small toy from Best Buy that a kid is flying in their backyard, probably not. But if they're flying at higher altitudes, participating in that airspace, which would require the drone to be a little bit bigger, carry bigger batteries. If they're carrying a sensor or a payload, then likely they would need to have some type of communication device on there if they are over a certain size. So I think so.
Very interesting. So tell us what your thoughts are about how soon we're going to be seeing increased use of drones in terms of package deliveries, in terms of possible transportation for all of us, which is, I guess, a dream many of us have had for a long time.
Yeah, I can remember growing up as a kid and on the Discovery Channel or History Channel, seeing the flying cars that everybody's building. And so I think we're finally on the verge of a lot of that coming to fruition. From a time scale, it's very difficult to predict. We're dealing with a highly regulated industry. Not only working with the FAA, you have to work with the FCC. There's efforts, especially at the congressional level, helping this along. Standards bodies, NASA's involved in participating. So it's something that we know it's happening. It's coming, both with air traffic control as well as with the flying taxis, because the demand and societal benefit is there. And so if we look at what the drone space, how the drone space has progressed over the past 10 years, I think that may give us an indicator of what that could look like for this all becoming a reality across the U.S., where not even 5 years ago, it was actually illegal to fly a drone for commercial purposes. And within those 5 years, the government has been able to write regulations that enable the flight of drones for commercial purposes. We see very large companies adopting drone usage at very, very large scales, especially what we've seen in the electric utility market, that's driving massive benefit to society. And so I think those factors and those pressure points are ultimately what is helping push this forward faster. Now, what holds that back is the mandate that the FAA have is safety of the airspace. So everything the FAA does is centric around how do we keep the airspace safe and the people on the ground safe. And so we're in a very interesting time and dynamic where the FAA and regulators are used to moving very slowly. Yet we have lots of technology startups, lots of even car companies now coming into the space and wanting to move that very fast. So we have this very interesting merge of very kind of innovative startup software companies now working hand in hand with legacy regulators, and those regulators are working actually very, very quickly compared to what they may have worked in the past. And so, I think we're on the cusp of being able to actually realize some of these, maybe starting with simple package deliveries in more rural areas, and those scaling up to, hopefully soon I can get a pizza delivered to my front door in the next couple of years. And on the flying car front, we're seeing very large companies investing very substantial amounts of capital into this space, where existing helicopter companies have even rebranded their entire companies to be focused on this, and car companies now saying we're going to build these. It's coming, and it's coming very fast.
Are some of the same technologies that are being used in trials, primarily with driverless or autonomous vehicles on the ground, are they relevant here?
They're absolutely relevant. So a lot of what's happening with the visual detection of different obstacles of what some of the car companies are doing certainly does apply to how we have to interact with the flight space of aircraft, where, today, even if I'm talking to air traffic control when I go fly, my small plane, or if I'm not talking to air traffic control, I still have to look out and visually look for other traffic so that I can keep myself separated from them. And so a lot of the technology that is being developed in the driverless car space, I think directly will apply over into both the drone space as well as the flying taxi space, because that will help act as what I would call a last mile avoidance capability, where as we're getting closer, if an air traffic control system for some reason has not been able to, one, detect another aircraft there or keep them separated, those types of technologies will become very important to act as a secondary level of safety to keep those aircraft away from each other. And so I think that's going to help substantially. But also what we've seen in even the consumer space of even drones, I think is going to help push this whole industry forward quite substantially, where a lot of times with this type of technology in the past, we've seen the military driving a lot of the innovation and then that trickling into the consumer space. With how popular drones have been over the past 10 years on the consumer space, that's actually been driving a lot of the innovation, cost reduction, miniaturization that's going to be required for a lot of these types of operations to take place.
What are the biggest challenges, obstacles, either technologically or otherwise, that you have to overcome for all this to grow the way you hope it will?
That's a great question. Implementing an air traffic control system is complex across many different fronts. The technology is complex because there are many different types of technology that have to work together. And the regulatory environment is extremely complex because this is ultimately going to impact the existing air traffic that's in the sky. It has to be done in a very safe way that the FAA can guarantee safety for all of those people. So from a technology standpoint, if you break it down, there are a couple of key things you have to look at. One is that communication. Today with manned air traffic control, the pilots verbally talk with the air traffic controllers. And so that's how the communication's done. It's done on protected spectrum. It's done in a way with using technology that's well proven out, that we understand very well. And so in order to merge this highly innovative drone space into this slower working regulation space, we have to work with some of the communication giants, the cellular companies, since cellular may be a viable option, and work with them to determine, how do we harden these systems? How do we make them more secure? They're already very secure, but how do we make them more secure since we're now dealing with public safety? And then how do I know that when I send a communication message, it's going to get to an air traffic control server within a specified amount of time? We can't afford really any lag. And so there's a lot of work being done by those cellular companies in order to start putting a lot of these needed resiliency efforts in place in order to really ensure that that system is going to be safe, secure, and very low latency for that to happen. And then very similarly on the back end, especially, this very well may be relying on cloud infrastructure to be able to scale in the future across the U.S. of how do we continue to harden and secure cloud infrastructure? How do we ensure connectivity with certain latencies, which is very big in aviation since things can be moving at very high speeds. And so that's the technological challenge. And then how do we certify all of that, maybe to a similar level of certification that's required for technology on manned aircraft. And then on the regulatory front, there are the challenges of this is a very new concept, although the idea has been around for a couple of years now. In the realm of aviation, it's a very new concept that the regulators are still working through. And so that's where efforts being led by NASA, by various other industry standards bodies, are helping move that process along in a way that we can conduct research, use that data from the research to build safety cases to show the FAA that this is the direction the technology needs to go and be approved so that it can be safe enough to implement a framework around what automated air traffic control could look like.
Where can people go for more information on the work that you're doing and perhaps about the patents?
Yeah, so absolutely. PrecisionHawk.com is our company's website. We have a blog there with a number of blog posts, not only about our core business, but what we've done in the past of creating some of these air traffic control technologies, testing them, the research. We've been involved in a number of research programs with NASA and the FAA, and we've written about what we've done, the benefits that's come out of that, and even kind of what our vision is going forward. And so we certainly will post that as well as some of the information about the framework that we believe one of these automated air traffic control systems could look like, and ultimately how that's reflected in our patents. We'll be posting all of that on our website, and we encourage anybody that wants to talk about it to reach out to us. We're really trying to work with the industry and make sure that we help enable the industry as a whole, so that we all can reap the benefits of some of these ideas of how drones can be used in the future.
Once again, the website is PrecisionHawk.com. Congratulations on the patents. Tyler Collins, thank you so much for taking the time with us.
Thank you very much for having me. I really enjoyed the conversation.
Now this. How many companies out there have continued to innovate when it comes to building a better radio? I'm Fred Fishkin, host of Techstination, and I'm here to tell you about the new CC Skywave SSB radio from the wonderful people at C-Crane. Bob and his crew really love radio, and it shows in this new compact model that is packed with features. Beyond great AM and FM reception and sound, you can tune into shortwave signals from around the world, listen to ham radio operators, aviation, and more. It's the radio you'll turn to every day, and in emergencies. It will run for nearly 3 days on just 2 AA batteries. Pair the sleep timer with the new Soft Speaker 3, and you've got the perfect radio for your nightstand. Of course, it can wake you up too. Click on C-Crane at Techstination.com and put in the code Techstination for a free flashlight with your order. They love radio, and you'll love C-Crane.